Okay, hello everyone. I'm Salar and this is a tutorial for writing a real-time operating system, and we are still talk about prerequisites for our project. In the last part, I started to talk about and teach about Make, and Make is an auto tool, and it can make our compiling process easier. And let's keep talking about Make. As you see, I have a test one project, and in my test one I have a single project with a make file. In my project I have a main file. It's a easy program, and it's print things multiply by 2, okay, with multiply function from header file. Okay, in my header file I have declaration of my function, and in the multiply.c file I have my definition of function. So let's open that in terminal. Control Alt and T for opening a session and a terminal, and in that cd to test one, and let's do nano my make file. In my make file I have a default code, my output. I can create output from, and Make creates output from main.o and multiply.o, two object files, and it's the recipe and command. And main.o itself creates from main.c, and its prerequisites is main.c and header.h. Okay, and it's command and a rule like main.o for multiply.o, and I create multiply.o from my source file, and I have dash capital I and dot for current directory because I include my header file in my main.c file in a curly bracket mode. Okay, so I need this option for compiling, and a funny target for cleaning my project, cleaning the file, object files and output file. Okay, let's talk about an option for cleaning. If I list my my file and folders in current directory, I don't have object files and my output file. And if I run make clean and press enter, it returns me an error, and it says RM can't remove your object files because you don't have any object files and output file. Okay, how can I prevent Make from returning these errors? Let's do nano make, but assume that I want to remove a file from my current directory, for example rm solar. I don't have solar file in my directory, and if I press enter, it returns me an error. How can I prevent terminal to return this error? There is a really simple object, -f for forcing remove. Okay, force remove, and it's not important that you have solar or you don't have solar. It should do removing work and doesn't return an error to me. rm-f solar. I don't have solar, but terminal and rm does not return an error to me. Okay, so let's open my make file and add this option to my remove. Okay, so important because when you want to run make, it's important you that make does not return an error to you. Okay, I want to create my project with make without any errors. It's so important for me. And let's just save that. And another time, I don't have object files and output file, but if I run a clean target, it doesn't return me an error. Okay, so as you saw, it's my make file, structure of make file, and let's do draw the dependency chart with a graphical environment. Okay, so what's my default goal? My default goal is output, and output depends to main.o object file and multiply.o. Okay, and main.o depends to main.c and header.h. Okay, another time mul.o depends to mul.c and another time header.h. Okay, it's my dependency chart, and when I start make first create main.o with its recipe. After that create mul.o, and after that with these two object files create my default goal and create output. Okay, let's do run make in an easy way. Just make. You don't want to write gcc and or option and your options and your paths to your header files and any other things. Okay, just make. Press enter. First create main.o, after that multiply.o, and in the last part create output from main and multiply object. And if I run my output, here is my output. Okay, it's easy work, and it's automatic work with make. Let's remove this all color lines, and is it important to add header.h to my rules? Is it important? I can say it's not important, because for example here for creating multiply.o from multiply.c, the content of header file is a declaration of function, and when I change header file, I should and I must change multiply.c, because when I change declaration of function, I should change the definition of function. And when I modify header file, I must modify multiply.c. So when multiply.c is newer than multiply.o, make run multiply.o, make run this rule. Okay, when I modify header.h, I should and I must modify multiply.c. So multiply.c is newer than multiply.o, so make runs this rule. Okay, so I can't ignore header.h from here, and in the same way I can delete header.h from my prerequisites of main.o target, because when I change header.h, I must and I should change the calling form of main when main, for example, want call a multiply, it should call multiply in the new form of multiply. Okay, so when I change the declaration of function, I should change the calling from files. Okay, so I can remove header from my prerequisites. Okay, let's do remove that. For example, assume that I remove header from here. Okay, assume that I remove header from my dependency chart. Let's do remove header from my dependency chart. Nano make file, and let's do remove that. And I don't have here. Okay, I don't have here. It's not important. For example, let's assume that I remove header from here. Accidentally, I didn't write header for multiply.o. So it's not important. I said it's not important. Let's do save that. Run make clean, and another time run make correctly runs my compiling process. Okay, and if I run my output file, I have no problem. Okay, but there is some important things. Okay, there is some important things. Sometimes you accidentally and unintentionally. Okay, let's do write that here. Accidentally and okay, accidentally and unintentionally remove add something to your header files. Okay, for example, let's do that. For example, assume that I accidentally add something wrongs in my header file. For example, I change my header file and my header file is here. Or for example, let's assume that I remove int from here. My header file is incorrect. Okay, is incorrect. And let's just save that, and another time run make. Okay, my header file is incorrect, but make don't know about that, doesn't know about that. Why make doesn't know? Because I accidentally change header file. Okay, and header file is not in prerequisites of main.o, mul.o, or main.o. Okay, and make just run your compile process just when you change multiply.c and main.c, because now header it's not in your prerequisites, so you can't find your problem in your code and your bugs in your code. So it's so important to change your make file and add header file to your prerequisites. Well, let's change make file and add header.h here, and another time header.h here. Okay, save that, and another time run make. Make returns me an error. Okay, my compile time returns me an error because in this time make says that header.h is newer than multiply.o and newer than main.o, and another time run this compiles, okay, and find your problem in your code. So when you add a header to your file, for example, a header to your main.c for creating a multiply.o, make sure to add header file to your prerequisites, okay? Make sure to add your header files to your prerequisites because it can prevent future mistakes and problems, okay? It's so important because sometimes you change your code accidentally and unintentionally, sorry, okay, because sometimes you unintentionally and accidentally change your header file, but don't change your definition of function or calling from header file and function, okay? But another time. Let's do header and resolve my problem, okay? Save that and another time run your make. Now my project is true, my make file is true, my header file is true without any problems, and make run my compiling process. 6 multiplied by 2 is 12, okay? And it's so important to add your header file to your prerequisites, okay? You want to create, for example, main.o from main.c, and you include header.h to your main.c, so you should write header.h as a prerequisite, okay? So it's not needed, but it's so important because many of them and almost we are not careful and we have a lot of problem in our code, and make can prevent these problems and these bugs in your code, okay? Because almost we are not careful programmers and we have a lot of mistake in our codes. So let's do another time run make clean, and after that another time run make, because make want to create my project from scratch and I don't have any object file and output file. Make run all of this, let's do all of this dependency chart, okay? So let's to change just main.c, okay? Let's change just main.c, multiply.c, and add and for example multiply by 1, okay? It doesn't change the concept of my function, but I modify my main multiply.c, okay? Let's just save that and another time run make. In this time make just run this rule and this rule, make just run this rule and this rule, but doesn't run this rule, okay? Doesn't run this rule because when you change multiply.c, this time multiply.c is newer than multiply.o, so run this rule, and when you recompile multiply.o is newer than your output, so run this rule, but make does not run this rule, okay? Because main.c and header.h is older than main.o, okay? So make just run those rules that's needed, okay? another time. It's my project main.c multiply.c and my header file, and it's my output file and my object file. Okay, run my output file. 6 multiplied by 2 equal to 12. Okay, let's see other project and another hardware project. Okay, let's do cd to home, and in this time cd to test2. Okay, it's a project. I have my main.c multiply.c. In this time I have divide.c, my header file and my make file. Let's just see that in GUI. It's my main.c, like previous project, printf 6 multiply by 2, and in this time divide. I have divide function. Okay, it's my header file. I have definition of my divide, and it's my multiply function. Okay, include header.h, and after that definition of my function, and it's my make file. Let's do open that internal. Okay, I'm in test2, and let's do nano make file. As you can see, I have a default goal, my output from 3 object files, main.o, multiply.o, divide.o. Like previous project, create main object from main.c and multiply object from multiply.c, and I should add header file. It's not needed if you don't write header.h here. It's not a real bug and real problem to your project, and make can runs, but sometimes you accidentally change your header file, and it's so important to write your header file here because you are not careful. And in this time I have another divide.o. Okay, from divide.c and header, and my funny target for cleaning. Let's run my make first. Independency chart, create main.o after multiply.o after divide, and from main multiply, and let's do here is my, I don't write divide.o here. Okay, let's do make clean and another time make. Okay, and this time from main.o, multiply.o and divide.o, create your output file. Okay, so as you can see, assume that I have a lot of C files, for example 100 of C files. I should write 100 of rules, and it's so hard. And we use make for automating our project and make our project easier and much easier. And if I want to run hundreds of rules, I can have a lot of error and a lot of problem in my make file, and it's so hard. So how can I easy and make easy my work, and how can I write make file easier? And there is some options in make that can make our work easier, and we can write or make file in easier mode. Okay, what's that? It's pattern rule. You saw that you should write your rule, for example, let's write just my target and prerequisite, for example, output from main.o, multiply.o, and divide.o. Let's do just write targets and prerequisites, and main.o from main.c. Let's do, don't write header file now here, but I add it to my make file in future. Okay, and multiply.o from multiply.c and divide.o from divide.c. I can't see there is a 3 similar target and prerequisites. Okay, so I can write that here, like here, person.o from person.c. Okay, it's a pattern rule. It's a pattern when you write your target and prerequisites right here. It's pattern rule. What it says that you want to create object files from your C files in your current directory that you run make. Okay, in your run make, and in the make, search in your current directory and find all of your C files. Okay, and itself create these rules automatically. Okay, create these rules automatically. And so how can I write my recipe in this pattern rule? For example, you see that here I should recipe for main, but here I should recipe for multiply. Let's do see the make file. You can see here I should see main.c and main.o, but I should write main multiply.c and multiply.o and divide.o and divide.c. Our recipe is not completely similar. So how can I write my recipe in this way, in pattern rule, with automatic variables? What is automatic variables? If I want to write my recipe in this form, I should write, for example, gcc -c is similar to all of rules, and -i point is similar to all of rules. But how can I write my C files? Okay, how can I write my C files? You should write a $sign and a hat. Okay, $sign and a hat. And how can I write my target? $sign and an @sign. Okay, these are automatic variable. Okay, variable. I will talk about variables in Makefile, but these are automatic variables. Okay, so when you write $sign and @sign to your recipe, it means your target file, and it means, for example, make want create a rule from your pattern. Create a rule from your pattern. It finds c.c from, for example, main.c from current directory, and it wants to create a main.o from your main.c because of this pattern, and it creates your recipe from this pattern. It's add gcc -c-i point, and after that, what this means all of your prerequisites. Okay, all of your prerequisites, $sign and hat. What this means, for example, here is main.c. It's similar to all of your rules. That's O. And what's this automatic variable? the value of this is your target file in your rule, and then make replace main.o here, and make can all of your rules from your C files with this pattern. Okay, with this pattern. So let's write that in my make file. I can remove all of my similar rules. Okay, now create that's O from your C file, and what's the rule? gcc-c-i, and point similar in all of your rules. After that, $sign and hat for all of your prerequisites. Here's just the C file -o, and after that $sign and @sign, and it means your target. Okay, it's a pattern. With this rule, this pattern rule, make will create all of your object files from your C files, and after that create your output file. Okay, and let's run that. Make clean and run make run all of my project. It creates my recipe automatically. gcc-c-i point and main.c and main.o. Okay, it create main.c and main.o from automatic variables, and it create their target and prerequisites from our pattern %.o semicolon %.c. Okay, and if I run my output file, 6 multiplied by 2 is 12, and 6 divided by 2 is 3. Okay, very easy. Very easy. Okay, just by pattern. So assume that you have 100 of C files. You have just one rule. So how can I add header here? Header.h. If I write header.h, because of this automatic variable, make will bring header in your compile. Okay, in your compile command. Let's run that. Make clean and another time run your make will bring your header file in your gcc command. It's not true. Okay, you can't write your header file to your gcc command. So how can I resolve this problem? Let's open my digital pen. I said that here is your target, $sign and hat is your all prerequisites, and I have another automatic variable. It's $sign and this arrow. Okay, what this means? First prerequisite. Okay, first prerequisite. If I write here $sign and this arrow, it just add main.c and will not add header. Okay, just main.c. Automatic variable means just first prerequisite. You can have a lot of prerequisite here, but this automatic variable bring just main.c to your compile command. Let's change my make file and resolve my problem. Arrow, okay, $sign and left arrow. Let's just save that. Make clean, and another time run my make. In this time, make brings just main.c, doesn't bring header.h to your compile command. Okay. If I run output, 6 multiplied by 2 is 12, and 6 divided by 2 is 3. And another time, for instance, let's do, for example, change multiply.c and add multiply by 1. It's not important, it's returned a, multiply by b, and multiply by 1. So useless change, but I modified my multiply.c, and now multiply.c is newer than multiply.o. And if I another time run make just run 2 rules, okay, 2 rules, not 4 rules. It create another time multiply.o from newer multiply.c, and after that relink your project and create your output file. And I have my output here. Okay, but in this time it's so messy. I have a lot of information here and so messy. Okay, it's my automatic variables. I have another automatic variables, and you can find those in make documentation. Let's see the make documentation. For example, make file doc. Here is a manual for Gnu Make, and you can read that. Okay, you can find, for example, let's do search for automatic variables is here. I have some other automatic variables, and you can read for them. Okay, so easy. You can read for your automatic variables, and all of make file documentation, Gnu Make. Okay, you can read that. It has a lot of information. But let's do change. Let's do run make clean, and let's do put my source file in a subdirectory. For example, let's create a new folder here, src, my subdirectory, and cut these files to source directory. Okay, I have source directory here, and if another time run make returns me error, because it's in pattern rule. It can't find your C file, in a pattern rule here. It can find C file in your current directory that you run make. Okay, your C files is in your subdirectory. So how can I change my make file to resolve this problem? I can add a source file here. Let's do source directory here. It now says to make file to find your C file from this directory. Okay, from this directory source. And let's do rerun my make. One more time make, it can run my project. Okay, it can run my compile and it's my output. So there is another option in a make file that can make your work much easier, and it's path of vpath. I can give path, it's vpath. Okay, it's vpath. Let's write that vpath. Okay, I can't give my path to your make file that can find my C files in them in this form. vpath search for your C file, for example, in src. Okay, I can write it here. vpath here, search for your C file from source, and I can remove that. Let's just save that and make clean, and another time run my make. In this time make file find my C file from source directory, and it replace source / and main.c in my command. Okay, it can make my work so easier, much easier than before, and it's so beautiful. Okay, let's run my project. It's my output. Okay, so vpath. So you can have, for example, vpath .h for example, your header file. Okay, I can take, for example, my header file to a subdirectory and give the path of my subdirectory in this way to make. Okay, for all of your files you can do that. vpath is the option for make file. Okay, in this part I talked about the importance of header file in your prerequisite, and you should add them. It's not when you don't add your header, your make file is true, but it's so important to add header file to your project because we are not careful programmer. We talked about pattern rules and automatic variables. What's pattern rule and automatic variable? Pattern rule is like here. Okay, %o from %c, and using automatic vars in your pattern rule. Here, structure up and format your target and prerequisites in pattern rule. Is like here, and you should use automatic variables in your pattern rules. And we talked about vpath, and for example %.c and your path, or for example %.h your path, and it can make my work much easier than before for writing a make file. Okay, so in the next part I will keep talking about make file and other option of make files, and thank you and see you soon.